Okay, so we've got a function here, and we are trying to find the subset of R for which the gradient of f is negative. Now, the quickest and easiest way to do this is actually just to get a quick sketch up of the graph. So we've got a function, and it's already in factorized form, which means we can probably graph it relatively quickly. You can get the x-intercepts just by making each factor within the function equal 0. So that would mean that x is equal to -5, or x is equal to 1. Really simply, that's all there is to it. Now, the x is equal to -5 is a repeated factor because it's the x plus 5 squared, which means that at that point we're going to create a turning point. So again, all this information should come relatively straightforward. If you need a bit of a refresher, check out the course, check out inside the course, and you'll be able to see how you can use these factorized forms to actually graph. So, really quick sketch, and again, I'm only using this to help you visualize. The x equals -5 intercept, we can mark there. And the x equals +1 intercept, we'll put about here. Now, this is a cubic function with a turning point at x equal -5, which means it's going to do something like this. All right? That's all there is to it. Once you've got a really quick sketch, you just have to think about which points would create this type of curve. Now, typically speaking, we don't really know what that turning point is, but we do know what this turning point is. This is -5 and 0. And you could use calculus to find this turning point if you need to. But we can now start to eliminate the problems. See, the question actually asks where is the gradient negative, and you can see really clearly that the gradient is negative for this portion of the curve. All right, which definitely means that it's going to start at -5 and finish at somewhere. All right, which means that we can eliminate A as not a possible option. B, we can also eliminate because we can see that the curve becomes positive before it gets back up to +1. C is a potential option. We could potentially say that this is -1. We haven't got enough information to know for sure yet. D is definitely not an option, and E could be an option. So at this point, we have to figure out where the turning point actually is. Now, unfortunately, you can't actually do this without a little bit of calculus. So all we do now, basically, is we take our little curve, and we going to have to expand it, differentiate it, find out where it equals 0 so that we can get an accurate representation of where that turning point is. So we can expand our curve. And once we've done that, we can just continue expanding. And just simplify it off, and once you've done that, you can differentiate it, and then from there you won't have any problem figuring out where the x-coordinate of that turning point is, because that turning point is where the gradient stops being negative. So we'll just finish this off by simplifying all of our pieces. Find the derivative, which you should remember from last year about how to differentiate a polynomial. And once you've got that, you can let it equal 0 and find the turning point. Now, really, because you know that you've only got two options, it can only be either -1 or 0, it's probably quicker to speed up this process just by letting the value equal either -1 or 0 and seeing which one would actually work out. Because the whole point here is we want to know where the derivative equals 0. But really, because it can only be either -1 or 0 that creates that scenario, we can just sub one of those values in. If it works, great. If not, cool too. All right. Now we can pretty much see that if we subbed in x equals 0, the gradient here would turn into 15. So if we were to sub in x equals 0, then you would know that the gradient equals 15. But if you were to sub in -1, you would have 3 times -1 squared plus 18 times -1 plus 15, which would give you 3 minus 18 plus 15, which is equal to 0. Alright, so the x-coordinate of -1 creates a gradient of 0, which means that the coordinate of this turning point is -1 and something. But the something, honestly, is not that important, because that means we can narrow it down and say that the answer is very definitely C. Alright, so my graph actually here, although it was quick and sketchy, is actually relatively accurate. Now that's pure fluke, and I wouldn't have known in advance if the turning point was at -1 or if it actually was on the y-axis. You don't really know that until you use the derivative to figure out exactly what you're dealing with.